We spend 1/3 of our lives sleeping, and still we don't know why we sleep. We know some functions, but overall it's still a mystery.
From the beginning of time, the lives of all living beings has been governed by the need for sleep.
Sleep is considered one of the critical, necessary components to life. If you don't sleep, if an animal doesn't sleep, it dies.
For us humans, modern lifestyles unfortunately mean that the notion of a good night's sleep has become a distant memory.
L'exposition à la lumière, même à des niveaux faibles, l'équivalent d'une ou deux bougies à 1 mètre de soi, ces luminosités très faibles vont être très défavorables à notre sommeil.
Le soir, il faut savoir lâcher prise et surtout ne jamais utiliser d'écran après 20 heures.
And that's one of the reasons that has contributed to this epidemic of sleep deficiency that is in our society.
Today, lack of sleep touches all generations.
L'insomnie, c'est très fréquent. On estime que presque 10% des adultes partout dans le monde sont vraiment des insomniaques sévères.
Si je ne prends pas quelque chose pour m'endormir, je ne dors pas. Je fais carrément des nuits blanches.
In the space of 50 years, we have lost 1.5 hours sleep per night. Faced with this danger, research has been stepped up around the world.
There's not a single system that is not affected by the lack of sleep.
The brain is so stressed out during normal wake time that it cannot do its normal housekeeping.
So how to get back the sleep which has been so neglected over recent years? Anything's worth a try, from the most natural to the most high-tech.
I don't face the night like I'm not going to sleep. I don't have that anymore. That's gone. In the space of 2 generations, we have lost about 30 minutes sleep per night. An average night's sleep around the world today lasts between 7 and 8 hours. Worse still, in many countries, 1/3 of 18 to 35-year-olds sleep less than 6 hours a night. Imagine the damage caused by this omnipresent blue glow in bedrooms when the time comes to sleep, and to what point it pushes daily life out of sync. Adolescents fall asleep later and later. Half of them suffer greatly from sleep deficit.
We share in common with many other species, plants, animals, insects, that the light-dark cycle is the most important synchronizer of our internal biological clock.
Professor Charles Czeisler is the father of modern chronobiology. The science of biological rhythms has led him to compare the effects of natural and artificial light. From the dawn of time, most living species have been bombarded by the white light sent down by the sun. White light is composed of a palette of colours ranging from red to violet, but primarily blue.
LEDs could not make white light because no one knew how to make a blue LED. So when the scientists discovered how to make a blue LED, that has created an entire revolution.
Until then, we used incandescent light bulbs with heated filaments. These were replaced by more ecological LEDs. And this is where the problem lies today. Since the advent of blue LEDs, each bulb in our houses emits the white light of a small sun. All our screens use this technology and bathe us in blue light without us noticing.
Now, the electric light to which we're exposed, in terms of resetting our internal clock, is like light on steroids. It's like got this tremendous peak in the blue part of the spectrum, it's telling the brain, oh my goodness, it's the middle of the daytime.
Our main biological clock is in the brain, behind the optic nerve. It is synchronized with sunlight and controls all our body rhythms. This clock is adjusted to a 24-hour day, the time of one rotation of the Earth. If we are exposed day and night to light which is not sunlight, but which the brain interprets as such, what happens?
As we have reduced the strength of the synchronizing effect of solar light and increased the disruptive effect of electric light, it has dispersed us because we don't think about, we turn on the lights to do things in the evening. After the sun sets, we turn on the light. We don't think about the fact that when we turn on the light, it is shifting our circadian rhythms to a later hour. So all of us on average, compared to where we would have been 200 years ago, we have shifted ourselves about 3 to 5 time zones westward. We've actually studied people here in Boston that are living in the same city, and their internal clocks are 12 hours apart. So, that's just sort of a mind-boggling finding. So one person's internal clock will be on Hawaiian time, and the other person's biological clock will be on Paris time, and they're both living in Boston. And then we wonder, why are we having trouble falling asleep at night?
This is precisely what Professor Claude Granfrier is trying to understand. For this, he carries out laboratory confinement experiments linked with rhythms of light sensibility.
L'expérience qu'on mène là, elle cherche à répondre à cette question-là, c'est-à-dire lorsqu'on a des intensités lumineuses équivalentes à celles qu'on pourrait avoir dans cette pièce, environ 150 à 200 lux, qui sont les intensités lumineuses qu'on a dans sa cuisine, par exemple, le soir après le coucher du soleil, eh bien, combien de temps il faut à cette lumière pour activer le cerveau?
To answer this question, Professor Granfrier is studying the influence of light on subjects who spend 3 days in total isolation, with no temporal reference points and deprived of sleep for 34 hours.
Je vous laisse vous installer.
Ouais, ça va.
Vous voyez, ça c'est votre chambre.
D'accord.
Et j'imagine qu'Inès vous a dit qu'il faudra retirer la montre, donc vous n'avez pas de montre.
Bah non, du coup, non, j'ai plus rien, j'ai mon téléphone que je vais éteindre, du coup.
D'accord. Loïc, on va fermer votre porte, et c'est le démarrage du protocole, cette porte-là.
D'accord.
Donc on la réouvrira jeudi. Ok. Allez.
Merci.
Juste pour te montrer un petit peu ce qu'on voit. Donc l'objectif, c'est de calculer la taille de la pupille en même temps que tu es exposé à la lumière. Et tu cliques au moment où la lumière commence à être gênante.
D'accord.
L'objectif de ces différents types de lumière, c'est d'activer différents types de photorécepteurs. Et donc ces mêmes lumières vont être répétées chez les participants toutes les 2 heures. Et ça va nous permettre de dire, est-ce qu'il y a certains moments de la journée où on est plus sensible à la lumière que d'autres?
Nos résultats montrent que ça prend entre 2 et 5 minutes à la lumière pour activer le cerveau, pour constricter la pupille, c'est très rapide, pour augmenter la fréquence cardiaque, c'est très rapide. En 2 minutes, on augmente la fréquence cardiaque. On augmente la température corporelle. Donc on voit bien que la lumière active énormément de choses dans l'organisme.
Melatonin, the hormone which induces sleep and is produced naturally in the brain, is particularly sensitive to light.
On a pu montrer qu'avec des niveaux de lumière qui sont très faibles, par exemple entre 1 et 2 lux, c'est-à-dire l'équivalent d'1 ou 2 bougies à 1 mètre de soi, on supprime déjà 10% de la sécrétion de notre mélatonine. Donc on est passé d'un stade où on pensait qu'il fallait des niveaux très élevés à une compréhension d'effets qui s'observent à des niveaux très bas, qui sont ceux auxquels on est exposé par exemple le soir dans son lit avec son téléphone portable ou sa tablette ou avec son ordinateur.
Incessant light has an impact on society as a whole. Day and night, swarms of people reply to a growing demand. 25 million workers are out of step in the United States alone, with dramatic consequences.
Shift workers who continuously shift from daytime to nighttime, flight attendants who are flying continuously across time zones, they have an increased risk of cancer. People who sleep 5 hours a night or less have a 300% increased risk of calcification of the coronary arteries. We've shown that when resident physicians work extended duration shifts, they make significantly more serious medical errors. They stab themselves more often with needles or scalpels. The more senior physicians have an increased risk of making a serious error in a patient during surgery. They have 170% increased risk of having a motor vehicle crash driving home from work. So there are many adverse effects of insufficient sleep and extended work hours.
Even if many people have no other choice than this badly aligned lifestyle, sleep can be improved by living healthily. Nutrition plays an essential role in adjusting the sleeping-waking rhythm and resynchronizing our nights. Professor Yves van Korter is an endocrinologist, a metabolism specialist at the head of a vast study into the links between sleep anomalies and obesity.
When you start analyzing hormonal data over the 24-hour cycle, you recognize that there are some events that have a major impact. And the one event that has the biggest impact is sleep. We are the only mammalian species that sleep deprive itself, so it's a behavior that is completely abnormal and artificial. We started inquiring about whether this behavior could actually be involved in the epidemic of obesity, which affects all industrialized countries on every continent.
Two hormones regulate our appetite. Leptin controls satiety, and ghrelin deals with hunger.
That was just amazing, that these two molecules measuring the blood were able to predict how much more an individual would be hungry due to that sleep restriction.
We know from previous studies that sleep restriction is associated with an increased intake of high carbohydrate and high fat foods. So one of the questions I have is what is involved in this increased drive for highly palatable foods?
When there's not enough sleep, everything goes wrong. So leptin goes wrong, and ghrelin goes wrong, and endocannabinoid is dysregulated, and there's not a single system that is not affected by the lack of sleep. So our study addresses that issue of how dietary intake can help synchronize or desynchronize the peripheral organs that are sensitive to dietary intake, which is many, many of them, from the brain clock.
Claudia is slightly overweight. She has agreed to participate in this study 1 week at home, then a week at the hospital. The aim is to better regulate her meals to allow the brain to rest at night and help her sleep better. Eating too often keeps the body awake, which upsets the essential fasting phase during the night.
So we have you sleep in the lab around the same times that you sleep at home. We'd ask you to wear this watch the whole time. You will press this button on the side when you wake up and when you go to bed. Okay. And then we have something called the constant glucose monitor. You ready? 1, 2, 3. There it is. That's it. So every night we're going to wand the sensor and we'll be able to see what you ate, when you've eaten across the day, and what your glucose levels were.
Oh.
Okay?
That's awesome.
Dark, sleep, fast. These three things have to be aligned for our biological clock to be able to control temporal organization in all the organs. The clock in the brain is synchronized by the light-dark cycle, but the clock in the liver doesn't see the light. So what is synchronizing the clock in the liver, in the pancreas, in muscle, and so on, is caloric intake.
The experiment is carried out on several subjects placed under different conditions. As Claudia settles into her hospital room, Eve van Korter and Erin Hanlon analyse the results of one of their first volunteers who arrived a week earlier.
So this subject was their first subject, and he was randomized to the extended overnight fast. And his biggest meal always in the evening.
Okay.
And fairly late, starting at 8. For an American, that's late. And day after day, this is the mean of 5 days. You cannot see where the overnight fast is. It looks like his glucose levels are all over the place across the 24-hour cycle. And then you can see that he is definitely pre-diabetes.
Yeah.
The lower curve is our intervention, and there we can really see that we change the glucose levels to a clear, low overnight fast, breakfast, lunch, dinner. So I'm really excited.
As a result, the patient's quality of sleep has clearly improved.
The brain is a glucose guzzler. It needs glucose, it's its main fuel, and it uses more glucose than any other organ. As soon as you fall asleep, your brain is not using as much. So the metabolism is slowed down drastically. So what happens when you eat very late, instead of having the glucose go down in 3 hours, it takes 5 hours, 6 hours. So most of the night, now you have high glucose levels. The signal to the brain is that we are awake. Sleeping over high glucose levels is going to deteriorate sleep quality.
The study highlights a terrible vicious circle. The more often we eat, the less we sleep. The less we sleep, the hungrier we become. How can the brain rest if a too frequent intake of rich food leads it to believe that it is permanently awake? Clearly, our bodies are incapable of adapting to the habits of modern-day life. Too many changes in the space of a century have had a direct impact on our sleep. In a similar way, our bodies find it difficult to adapt to the increasingly sedentary nature of our lifestyles. At the University of Caen, Professor Daven works in the domain of biological rhythms and is looking to determine the consequences of physical activity on the quality of nighttime sleep.
Intrinsèquement, l'Homo sapiens est fait pour bouger, pour se dépenser 3 000 à 4 000 calories par jour, c'est pas aberrant. Ce qu'il y avait dans les sociétés encore jusqu'au XXe siècle. Il y avait une dépense énergétique quotidienne qui suffisait pour se maintenir en bonne santé. Aujourd'hui, on a perdu ça. L'objectif, c'est de regarder si l'activité physique ponctuelle, pendant une journée, a directement et immédiatement des conséquences sur la nuit suivante. Le fait de faire de l'activité physique, c'est sécréter des hormones de l'éveil. Donc il faudra éliminer ces hormones de l'éveil pour ensuite s'endormir et avoir un bon sommeil. Et plus l'activité physique va être intensive, par exemple un squat très violent et très répétitif, où on se dépense beaucoup, plus ça sera difficile de s'endormir après. Il faut vraiment faire retomber la pression, il faut que la température revienne à un niveau normal avant de faire une bonne nuit de sommeil. Donc on en est arrivé à se demander quel type d'activité physique allait modifier le sommeil, et on en a conclu que c'était l'activité physique de type aérobie.
Aerobic exercises correspond to long endurance activity. In this case, muscles draw oxygen from cells, unlike what happens during more violent exercise. Once the physical test is over, Professor Daven analyses the sleep of the subject.
On regarde si le sommeil est plus intense, et ce qu'on quantifie dans le sommeil, c'est surtout le sommeil non profond.
Donc là, il est encore réveillé, avec une activité musculaire importante. Mais il s'endort assez rapidement. Ça, c'est ce qu'on appelle des spindles, c'est-à-dire une activité qui traduit une volonté de s'endormir.
L'activité physique optimale, c'est l'activité physique que l'on fait en fin d'après-midi. Les conséquences sur le sommeil sont idéales.
Endurance sports carried out in the late afternoon realign the internal clock, making it much easier to fall asleep when nighttime arrives, and improving the quality of slow-wave sleep. Nowadays, the combination of abundant artificial light, poor diet, and lack of exercise is at the root of a lot of insomnia. Other factors, in particular stress and anxiety, also play a role. A third of French people regularly suffer from sleeping problems. 6 million are insomniac. They generally rely upon sleeping pills. Solitude, nighttime screen watching, our lifestyles perpetuate our daily troubles.
Je crois que je suis insomniaque depuis que j'ai 20 ans. Alors certainement, ça a dû arriver avant, mais à 20 ans, j'ai commencé à prendre des somnifères. Ça va? T'es content de me voir? Hein? T'étais tout seul, toi aussi? T'étais tout seul. Voilà. On va aller se promener. On va aller se promener. Je sais que pour bien dormir, il faut être dans une chambre complètement dans le noir et aller au lit que quand on a sommeil. Or, moi, je vais, quand je rentre à la maison, je vais effectivement dîner et puis, hop, tout de suite, regarder la télé, je ne vais pas le faire au salon, je vais le faire dans ma chambre. En même temps, je vais prendre mon ordinateur et je vais prendre aussi mon téléphone. Et je pense que ce n'est pas du tout les conditions idéales pour induire le sommeil. Mais je ne sais pas faire autrement parce que c'est des moments que je savoure en même temps. Mais quand je vais éteindre la lumière, c'est là où ça va devenir plutôt cauchemar. Mon rêve, ça serait d'arrêter ces médicaments.
600 million people around the world suffer from insomnia. A fifth of Americans admit to having taken sleeping pills. In Europe, Spain holds the record just above France, where 131 million packets of sleeping pills are sold each year. Trouble falling asleep or waking in the middle of the night, stress, anxiety. Insomnia has multiple causes and numerous facets.
L'insomnie, ça répond à des critères très précis, c'est-à-dire qu'il faut avoir des problèmes de sommeil au moins 3 fois par semaine, depuis au moins 3 mois, et que ces problèmes soient suffisamment sévères pour impacter la journée qui suit. Alors, ce qu'on va faire, c'est un enregistrement du sommeil complet pour bien essayer de comprendre ce qui se passe exactement au moment de l'endormissement et au cours du sommeil. Et puis après, on pourra s'orienter étape par étape pour essayer de dormir sans ou avec beaucoup moins de somnifères que maintenant.
A number of sleep cycles occur in one night. One complete cycle lasts about 90 minutes and contains 4 stages. 3 non-rapid eye movement stages of varying depths, and a rapid eye movement stage during which we dream. This cycle is repeated 4 to 7 times in the course of a normal night. Professor Léger prescribes luminotherapy treatment to help the patient out of her sleeping pill addiction. Sessions are particularly based on the use of blue light, because this colour amplifies the positive effects of natural light and increases daytime vigilance. It also regulates the biological clock and is effective against depression.
Donc, le principe de la luminothérapie, c'est de resynchroniser votre horloge biologique, vos rythmes de veille-sommeil. Vous pouvez commencer à pédaler.
J'aurais dû mettre des baskets, hein, je ne savais pas.
Voilà, donc c'est la surprise, ce sera pour les prochaines séances. Vous pédalez à votre rythme.
D'accord.
Voilà, donc c'est pas un marathon ni le Tour de France. Et puis vous pouvez regarder le mur, voilà, regardez la lumière bleue. C'est un traitement alternatif au traitement médicamenteux. Et je vous souhaite une bonne séance du coup.
Merci beaucoup, à tout à l'heure.
À tout à l'heure.
During the day, exposure to natural light combined with physical exercise improves the quality of our nights. We clearly construct part of our sleep during waking hours. Another principle can be used during the day, the nap. It's a fundamental approach to better sleeping. At the Sleep and Cognition Lab in California, this age-old discipline is studied. Sarah Mednick is a professor of psychology. She uses neuroscience research to demonstrate the central role which the nap plays in sleep management.
The purpose of the research that we're doing at UC Irvine is to understand what are the basic mechanisms of sleep that support cognitive function, including emotion regulation, memory, creativity, alertness. We look at what is the brain activity using electroencephalography, EEG, to look at specific sleep features that occur during that sleep period, either a nap or a nighttime sleep, and see how did those sleep features relate to the improvement in performance that we see before and after the sleep.
Mop, pumpkin, hanger, dog, mouse.
Okay, now we'll set you to sleep.
Great.
Time for nap.
So a nap, we would say, is anything from, say, 5 minutes to about 3 hours. The ideal nap time is usually about 6 hours after you've woken up. If you nap earlier than that period, you're going to have a nap that has more rapid eye movement sleep, REM sleep. If you nap later, you're going to have a nap that has more slow wave sleep. These are two very important sleep cycles, and they contribute to very different types of performance improvement. So it really also depends on how you want to tailor your nap to suit the goals of your sleep. If you wanted to have more sort of study help in terms of learning your history lesson, maybe you want to sleep with more slow wave sleep and you don't really need REM sleep. Versus if you're somebody who has to come up with some creative ideas that will require REM sleep.
Let me know if I pull it all, okay?
If you wanted to just have a quick alertness reset button booster, then you would just have these short power naps, these 30-minute naps, and you could do that any time during the day.
A nap is often necessary when we feel sudden weariness or a lack of concentration. But insomnia is not the only source of these symptoms. Sleep pathologies with physiological origins may also affect our powers of concentration and daily fitness. A case in point is sleep apnea, an underestimated major health problem which affects half of under 40s. In the Charité hospital in Berlin alone, 8,500 patients come for consultations with the team of Professor Penzel, a world specialist in this pathology.
Schlafapnoe ist eine Erkrankung, die von der Pathophysiologie her offensichtlich über das neuronale System gesteuert wird. Die Nerven im Kopf halten die oberen Atemwege nicht mehr auf. Es ist eine neuronale Koordinationsstörung.
Wenn man dann sehr stark schnarcht und der Atemweg komplett kollabiert, geht gar keine Luft mehr rein. Es ist wie die Luft anhalten oder wie erstickt werden. Es kann bis zu minutenlang dauern, während man schläft. Man merkt es nicht.
Aber dann wird die Luftnot so stark, dass der Körper sagt, wache auf, wache auf. Und man muss dann wieder atmen. Das heißt, der Körper hat auch gar keine Zeit, richtig in den Tiefschlaf zu kommen.
Der Schlaf wird dadurch sehr schlecht. Nicht nur der Schlaf wird schlecht, sondern auch alle Organe werden durch den Sauerstoffdefizit, der durch dieses Luftanhalten entsteht, stark beeinträchtigt. Das heißt, auf lange Sicht ist Schlafapnoe ein großer Risikofaktor für kardiovaskuläre Erkrankungen, aber auch für Hirn-, neurodegenerative Erkrankungen sowie alle möglichen anderen Erkrankungen, Tumorerkrankungen etc.
Penzel and his team have launched a study of patients suffering from various levels of this pathology.
Einmal bitte festhalten. Das habe ich. Brust- und Bauchgurtfunktion kennen Sie, ne? Dann messen Sie Ihre Atembewegungen. Wie sich die Bauchdecke und der Brustkorb beim Atmen hebt und senkt.
Das ist schon grüßlich. Wann ist der Termin?
Wir haben natürlich wie immer zu viele Männer.
Okay. Und Schweregrade waren das auch?
Ja, es war auch vorgegeben, wir wollten ja 40 eigentlich mit einer moderaten
okay.
Schlafapnoe.
Ja.
Nur 12 drunter, also eine milde Schlafapnoe und 8 eine schwere Schlafapnoe.
Okay.
Genau.
Ja, das ist ja ganz gut.
Das ist ganz gut. Wir wollten jetzt noch einen 4. Platz öffnen.
Wir wissen, dass Schlafapnoe bei Männern auch bei Übergewicht oder bei einem kurzen Kinn viel häufiger ist. Die weiblichen Hormone, Östrogen, die schützen vor Schlafapnoe. Frauen holen auf. Nach der Menopause bekommen Frauen auch mehr Schlafapnoe und haben dann ähnlich viel Schlafapnoe wie Männer.
Auf die Nase drauf, also so.
At the moment, a mask, not always easy to wear, remains one of the best solutions.
Maske, die dann wirklich. Genau. Ja. Wie fühlt sich das erstmal so an? Sie hatten tatsächlich hier 70 Atemaussetzer pro Stunde. Hier wird es dann nochmal aufgeschlüsselt. 268 Mal sind die ganz zugefallen, das sind die Apnoen.
Ja.
Und in den Tiefschlaf, der wäre hier unten, kommen sie tatsächlich die ganze Nacht gar nicht.
Mhm.
Und dann gehen wir jetzt über zu dem Befund aus der Nacht, wo Sie jetzt mit der Schlafmaske geschlafen haben. Sie hatten welche Maske, die Nasenstöpselmaske oder die ganze?
Vollmaske.
Die Vollgesichtsmaske, ja. Okay, alles klar. Man sieht hier schon ganz eindeutig, dass wir hier tatsächlich nur noch 2,5 Atemaussetzer pro Stunde hatten. Also es ist ein
sehr bedeutsam.
Ein extremer Unterschied. Das bedeutet, mit der Maske hatten sie tatsächlich eigentlich keine Schlafapnoe mehr. Und was wir auch halt gleich sehen, ist die Sauerstoff...
Sleep apnea can be cured, but only once you know you're ill.
Schlafapnoe ist eine riesige Public Health Problematik, die zum großen Teil völlig vernachlässigt wird. Die Politik, sowie die Ärzteschaft, sowie alle Patienten müssen dringend mehr tun, um dieses Thema in der Öffentlichkeit publik zu machen, weil es so wichtig ist. Und der gesundheitliche Schaden, der dadurch entsteht für den Patienten sowie für unser gesamtes Gesundheitssystem, ist riesig.
Sleep apnea, insomnia, desynchronization of our biological rhythms because of modern lifestyles. Whatever the causes, lack of sleep affects our health. Behind the fatigue and evident somnolence, many other invisible mechanisms are at work in our brains. Professor Chiara Cirelli has discovered a particularly insidious phenomenon. Continually disrupted nights inhibit DNA reparation at the heart of cells.
We found in several cells, neurons, in flies as well as in mice, double-strand DNA breaks. Now, this is a damage to the DNA that is quite potentially extremely dangerous because if it doesn't get repaired, it can cause then cell death. Basically, with sleep, the repair happens more quickly and more efficiently.
Today, she continues her research by targeting the toxic waste which proliferates in the brain cells of sleep-deprived flies.
These things here, so black, which is called the lysosomes, these are places where the waste of a cell gets digested, or if it's not then possible to actually degrade this material, it gets accumulated into the neurons and it stays there forever. Where were they?
With age, this type of waste accumulates naturally. Chiara Cirelli has noticed abnormal quantities of this waste in very young individuals lacking sleep.
So that was a first indication there is some kind of stress for the cells to be awake for too long.
This neural stress also inhibits the smooth running of a major biological function of sleep, our nocturnal treatment of memory and the sifting of what we have learnt.
Yeah, that's nice. So this is neuron A and this is neuron B, and where they touch and they are in contact with each other, this contact is called the synapse. It is this contact that allows brain cells to communicate to each other. When you are awake, because you are always learning something new, these connections get stronger, which is very good. The problem is that the brain is quite full. You can't just keep growing. There isn't much space available in a mature brain. You need a process that renormalizes the synaptic strands. And sleep is the time when it's safe to do that because you are not connected to the environment. So you are not a slave of the here and now. Can you show me how it looks like in 3D? And we see that these synapses grow after wake and they shrink after sleep. And we think that these connections are the way not only neurons communicate to each other, but also the way we keep everything that we know, all our memories. So when this renormalization happens, it has to happen in a smart and selective way that allows you, yes, at the end of sleep, you have consolidated your memories, and on the other hand, you have also forgotten, actually, things that are irrelevant.
So nighttime sleep allows the brain to organize the knowledge we have acquired and be ready for new information during the day. Consequently, memory is particularly sensitive to sleep deprivation. Bad sleep could be a risk factor at the origin of Alzheimer's disease. This is what Professor Maaike Nedergaard has discovered. As with her colleague, Chiara Cirelli, it all started with a story of waste.
The brain is so stressed out during normal wake time that it cannot do its normal housekeeping. And we speculated that this might be the biological foundation for sleep. The purpose of sleep is to clean the brain for all the waste product that build up during wakefulness. Nobody had really looked in the brain on how do the brain get rid of waste product. So we were starting to wonder, would glia cell be involved in that?
Glial cells are in a certain way the neuron's nannies. They bring them oxygen and food. Before Maaike Nedergaard's discoveries,
we were unaware of another major function of these cells. In the brain, arteries are encompassed by space in which cerebrospinal fluid circulates. As we enter deep sleep, glial cells open canals which liberate this fluid. It flows between the neurons, carrying with it the waste produced during waking hours. So these cells are the key to brain cleansing.
And once it's transported out of the brain here, it's dumped back into the blood circulation, and you can regard the liver as our professional recycling plant.
Doug Kelly is a fluid mechanics engineer. For the first time, he has made a model of this cleansing system within the brain of a sleeping mammal.
Here's the middle cerebral artery at the surface of the brain of a live mouse. Okay. And blood is flowing through it, but of course our interest is the cerebrospinal fluid that's flowing through the spaces around it.
Mm-hmm. So this is really what's happening when we are asleep, that we have all these many milliliters of fluid running through our brain to clean it. This flow is much more efficient when we're in deep sleep. If you're in lighter stages of sleep or if you're awake, it does not work. So the deeper you sleep, the longer you sleep, the better you clean the brain.
Micah Nedergaard has discovered that the waste evacuated by this fluid is amyloid beta, the accumulation of which is directly associated with the development of Alzheimer's disease. This ever-growing plague already affects 35 million people worldwide.
Once we get elderly and sleep less well, clearly we start to accumulate some of these waste products. And those waste products is viewed by the brain's immune system as foreign object because they're not supposed to be there. And the brain will start an immune response to remove it. And that immune response on long term is actually very damaging for the nerve cells. You have an increased risk of developing Alzheimer's if you don't sleep. The medical industry spent billions of dollars trying to block the production of beta amyloid, hoping that that would cure Alzheimer's disease. It didn't work at all, simply because it is not a production problem, it's a clearance problem.
Megan Nedergaard's discovery really helped to understand why Alzheimer's disease and other neurodegenerative diseases were more common in people who were chronically sleep deprived or in individuals who had obstructive sleep apnea and other sleep disorders.
These discoveries could lead to much more effective new treatments. The race for new remedies also depends upon the understanding of other mechanisms. One of them concerns narcolepsy, an illness where falling asleep can happen at any moment of the day. Discovering how to send someone to sleep in the twinkling of an eye is a long-held dream for researchers. Professor Emmanuel Mignot is a French researcher who has worked at the Standard Center for Sleep for 30 years. He studies this illness, which also affects dogs.
Watson, allez hop. Alors Watson est un chien narcoleptique. Et donc, comme chien narcoleptique, eh bien, quand il est content et qu'il est vraiment excité, eh bien, soudain, il devient paralysé, comme quand on est en sommeil paradoxal. Et là, un symptôme qui est très classique, c'est quand ils sont excités par quelque chose, par exemple la nourriture. Tous les gens qui ont des chiens, ils savent, c'est ça qui les rend vraiment contents. Attention, hop. Ah ça y est, on voit, hop, vous voyez, hop. Vous avez vu, là, il a commencé à devenir un peu paralysé des pattes de derrière. C'est tout, Watson? J'ai l'impression que le poulet, ça n'a pas l'air de marcher. Hein. C'est bon, hein? Oh, on va lui donner autre chose. arme atomique. On va essayer le sucré. Ah, ça y est, oui. Vous voyez, il ne peut pas le prendre, là. Il est parti. Mais en fait, il est partiellement paralysé, vous voyez? Il ne peut plus bouger. Il ne peut pas réussir à prendre le morceau. Hop, vous voyez? Il est complètement flaccide. Ça s'appelle la cataplexie. Alors, il a mais absolument pas du tout de tonus musculaire, vous voyez? Complètement. Et non, ça c'est rare, hein. Enfin c'est rare, mais... Et vous voyez qu'il est réveillé. Hop, il repart. Oh oui, il pensait bien, il n'avait pas oublié son morceau. Pas fou l'animal. Allez, on range. Mais oui, c'est triste, hein. Toutes les bonnes choses ont une fin, c'est toujours comme ça, hein. C'est vraiment... Ça, c'est le truc qui marche pas, mais t'en fais pas, c'est pareil pour les hommes. Je me suis dit, bon, ces chiens, il faut absolument qu'on trouve la cause de leurs problèmes. Parce que chez l'homme, on n'arrivait pas à trouver la cause de la narcolepsie. Alors, trouver la cause d'une maladie humaine, c'est pas tous les jours.
What Professor Mignot discovered is nothing less than the mechanism which turns the brain on or off. He realized that a hormone, baptized hypocretin, plays the part of the on button, stimulating wakefulness. By learning how to deactivate it by turning it off, the muted hypocretin allows sleep.
Et maintenant, il y a des médicaments qui peuvent bloquer le récepteur de l'hypocrétine. Donc, ça vous rend somnolent, ça vous fait dormir, vous êtes narcoleptique pour une nuit. Donc, il y en a un qui est déjà développé aux États-Unis, qui s'appelle le suvorexant.
Sleep. Remember when it welcomed you like a friend? Then it became more elusive. But why?
Le problème, c'est que, comme toutes les premières générations de médicaments, celui-là, il dure un peu trop longtemps. Donc, quand on le prend, on est un peu somnolent le matin. Donc, ça ne marche pas très bien. Mais c'est parce que c'est la première génération de médicaments. Il y en a plein d'autres qui maintenant arrivent, que d'autres compagnies sont en train de développer, qui vont durer moins longtemps et qui vont être plus actifs et qui vont probablement être des médicaments très utiles pour l'insomnie.
Sleep.
The race for new generation drugs is underway. But parallel to this, other much gentler approaches are reaching the brain and simplifying sleep. Fisher-Wallace Laboratories have developed this headset, a cranial electrotherapy stimulation device.
Insomnia really is our biggest market because it connects to both anxiety and depression. The principle of the device is as follows. What we're doing is we're creating a gathering effect in the brain. We are stimulating neurotransmitter activity, and then there's an off period. That the device lowers cortisol, which is the stress hormone, and dopamine, serotonin, and beta endorphin are the primary neurotransmitters that the device stimulates. It appears that the rate of increase of these key neurotransmitters is about 200% in the course of a 20-minute period, which is really significant, and much more significant than with drugs.
This young woman of 37 suffered from serious sleep problems, which she overcame by using this headset, approved by American health authorities.
I have suffered from depression since I was a young child. Have had a lifelong battle with anxiety and sleeplessness. And in 2011, I had a series of events that what I know now is post-traumatic stress disorder. The condition severely began. I experienced night terrors. My body just trembling with anxiety in the night when I would just wake up. I experienced flashbacks and pain throughout my body, pain level 9, 8, migraines.
What are you doing, silly? You're goofy.
So sleep was at times non-existent in my world. So black goes to black. It's that simple.
A 20-minute session every 3 or 4 days has literally changed her life.
And now here it comes. Here comes electricity. And I can feel the pulsing. It's slight and a little tingly. I'll take it to its max. If I close my eyes, I can see pulsing. Immediately, I felt like a wave of relief from the device. It was as if someone had gone through and dusted off pain in my body. I don't face the night like I'm not going to sleep. I don't have that anymore. That's gone.
Finding sleep is about finding a healthy life. Sleeping and eating at fixed times, doing physical activities, and of course, avoiding screens and harmful light sources as much as possible. By respecting sleep and our rhythms, let's strengthen our memory. Goodbye to fatigue and stress. So sleep well and sweet dreams.